Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss the concepts of evaluating outcomes reported from an interventional clinical trial. The most typical example of an interventional trial is a randomized controlled trial, RCT. In an RCT, the study population is randomized to either placebo pills or the active intervention. In both arms, some people respond while the others do not. In this 2 by 2 table, the four groups are plotted. The two treatment arms are plotted along the rows. Unlike the previous examples where we used exposure to risk factor E on the rows, here we are using exposure to treatment T for the rows. The outcome of interest, presence or absence of either beneficial or adverse effect, is plotted across the columns. This is written as outcome present or outcome absent, and the word outcome can represent either the beneficial effect or an adverse effect that you are interested in. Cell A represents the number of individuals in the experimental, that is, the active treatment group, who show the outcome of interest. Cell B represents the number of individuals in the experimental group who do not show the outcome of interest. Cell C represents the number of individuals in the control group, the group that received the placebo control intervention, who show the outcome of interest. Cell D represents the number of individuals in the placebo group who do not show the outcome of interest. The totals are shown in the last row and the last column. Total number of subjects in this study is A plus B plus C plus D. A plus C represents the number of subjects showing the outcome in total, irrespective of the arm to which they belong, the intervention or the placebo arm. B plus D represents the number of subjects not showing the outcome in total. Overall, A plus B subjects are randomized to the active arm. C plus D subjects are randomized to receive the placebo intervention. In a randomized controlled trial, even before the outcomes are known, there are two definite groups right after randomization. These are the placebo or the control group, and the active treatment or simply the treatment group. How can we describe the characteristics of these two definitive groups once the trial is completed and the results are available? In this table, A plus B patients received the treatment. Of this, A got better. The ratio A by A plus B gives the proportion of people in the experimental group that experienced the outcome. This is called EER, or experimental event rate. Look at the table again. C plus D patients received the placebo. Of this, C got better. The ratio C by C plus D gives the proportion of people in the placebo group that experienced the outcome. This is called CER, or control event rate. Similarly, we can also define the odds of outcome among exposed. This is given by number of outcomes divided by number of no outcomes in the exposed group. This is equal to A by B. The odds of outcome among the non-exposed is given by number of outcomes divided by number of no outcomes in the non-exposed group. This is given by C by D. When I say exposed, here I meant exposure to active intervention. You can see that these terms are very similar to what we used in a cohort study. So the odds ratio calculated in a randomized controlled trial is same as the odds ratio that you calculate in a cohort study. It's given by the relative odds of having the outcome if you're in the treatment group compared to controls is equal to odds of outcome in the treatment group divided by odds of outcome in the control group. A by B divided by C by D. AD by BC. This is nothing but a cross product ratio. As I said earlier, this is the same as what we got from a cohort study. Now, we have two risk values, EER and CER. We can now calculate the risk difference. Risk difference is also known as absolute benefit increase, ABI, because it is the same to say risk reduction or benefit increase. The term ABI or the term ARR, which stands for absolute risk reduction, are more commonly used than the term risk difference. ARR is given by the difference between CER and EER. In this plot, the total number of events in the treatment group and the placebo group are shown. The events that can be actually attributed to the effect of the treatment are those that additionally occur in the active arm over and above those that are seen in the placebo arm. This is shown in red. This is what we denote as ARR. As we have two risk values, we may as well calculate a ratio from them. Risk ratio or relative risk is the fraction of the two event rates obtained earlier. Relative risk or risk ratio RR is given by EER divided by CER. It can be interpreted as the probability of an event occurring in the treatment group, that is the experimental group, compared to the probability of the same event in the control group, that is the placebo group. From the 2 by 2 table, this is given by A over A plus B divided by C over C plus D. Another measure we can derive from RCT outcomes is relative risk reduction, RRR. Relative risk reduction, also known as relative benefit increase, is given by 1 minus RR. It is generally expressed as a percentage. Relative risk reduction is nothing but the risk reduction in relation to the baseline risk rate in controls. In other words, if you express ARR in terms of the baseline placebo response rate, which is CER, you will get RRR. So 1 minus RR is an easier formula to calculate RRR. When computing RRR, always consider the absolute value and ignore the sign. Finally, let's see the term NNT. This is considered to be more useful for patients. NNT is the number of patients that need to be treated for one to show additional response. It's given by the inverse of ARR. As it is a number referring to number of people, it is generally rounded to the next highest whole number. One mistake I often see trainees doing when calculating ARR is ignoring the percentage sign and taking the inverse of the whole number. Remember, N and T can never be less than 1. N and T can also be calculated from RRR and CER. We know that N and T is 1 by ARR. We also know that RRR, as I showed in the previous slide, is same as ARR divided by CER. From this formula, we can now say ARR is equal to RRR into product of CER. Thus, NNT is nothing but 1 by ARR or 1 by RRR into CER. Let's now consider the term PEER. In your clinical practice, you do not give placebo. So you cannot calculate CER outside of an RCT. But you may know the estimate of patients that are expected to respond without any treatment in your area of practice. This number, this figure, is called patient expected event rate, or PEER. This is also called the baseline response rate. PEER is useful to calculate NNT applicable to your clinic. Let's see how in the next slide. We saw how NNT is equal to NNT is equal to 1 by RRR into CER. We know PEER is the control event rate in local population in which the intervention is planned. In other words, PEER is nothing but new CER that is applicable to your clinic. So to calculate NNT new, we now need to replace CER by PEER in the above formula. Just going back on it, NNT new is given by 1 by RBI or RRR into PEER. So I've replaced CER by PEER. So a little bit more on NNT. If the event evaluated in an RCT is a negative event, for example, development of an adverse effect, then NNT is termed as NNH, number needed to harm. The formula is the same. It's the inverse of ARR. Note that NNT or NNH can never be a negative value. The values of NNT range from 1 to infinity. The ideal NNT is 1. This means we need to treat only one patient to get one additional response. In general, n less than 10 suggests a significant usefulness of a treatment. NNT of 10 to 20 is acceptable for prophylactic measures, such as vaccination. From a randomized trial, we have derived absolute risk in the placebo group, which is CER, absolute risk in the active treatment group, which is EER, odds ratio, risk difference, which is nothing but ARR, also called ABI, risk ratio, which is nothing but relative risk, and relative risk reduction RRR. This is also termed as RBI. Finally, we also derived number needed to treat, NNT. Now, an exercise to calculate NNH. There are two groups described here. A group taking risperidone, the experimental group, and the group taking placebo, the control group. The outcome of interest is new onset hyperlipidemia. Calculate the NNH. To do this, you first need to understand the control event rate is 5% as shown in the graph. The red bar touches the number 5. Experimental event rate, the event rate for risperidone, is 20% as the blue bar touches 20. Risk difference, the difference between the two event rates, is given by 20% minus 5%, which is 15%. Now the relative risk RR is equal to 20% divided by 5% is equal to 4. You do not need the relative risk to calculate NNH, though I'm showing this for the benefit of your understanding. Relative risk reduction is given by 1 minus 4, which is 3. We can ignore the negative sign. Now, number needed to harm is nothing but 1 by ARR. Now, we have established the ARR is 15%. So 1 by 15% is nothing but 100 by 15. So you will get number 7. This is the number rounded up to the nearest higher integer. This is the NNH value from this example. Some more calculations here. So I've shown 3 scenarios. In the first scenario, a group of depressed 60-year-olds were treated with oral SSRIs rather than placebo. Over 3 years, 2.9% of the SSRI group developed hyponatremia, while 1.9% of the placebo group experienced this event. What is the absolute risk reduction and what's the NNT or NNH? The next example, patients with myocardial infarction are treated with beta blockers, and we're evaluating whether the frequency of depression, the proportion of people with myocardial infarction who develop depression over 2 years is different between the groups who are treated with beta blockers and the groups who are treated with other cardiovascular interventions. We observe that of people who are treated with beta blockers, 7.3% develop depression in a period of 2 years, while people receiving other treatments, the event rate is higher, which is 9.8%. What's the ARR and what is the ANNT? The third example, patients with first episode psychosis are treated with SSRIs in combination with antipsychotics, and we are evaluating whether the addition of SSRIs will improve the rate of response to negative symptoms over 5 weeks period. We observe that in people who do not receive SSRIs, the event rate is 9.2%, but in people who receive the SSRIs in addition to antipsychotics, the response rate is 12%. What is the ARR and what is the NNT? The answers are given here. So here EER is 2.9% and CER is 1.9%. If you subtract these two numbers, you will get 1% as the absolute risk reduction value. NNT is 1 divided by 1% or 100 divided by 1, and that will give you 100. For the next question, the EER is 7.3% and the CER is 9.8%. We are calculating the rate of a negative event, that is onset of depression, and this is why the control event rate is higher. So a subtraction of these two numbers will give you a 2.5 and an inverse will give you 40. Now for the last question, EER is 12%, CER is 9.2%, ARR is 12 minus 9.2%, which is 2.8. This will give you an NNT of 36. Please remember that I have not ignored the percentage sign in each of these calculations. So it's very important to keep the percentage intact when you calculate NNT from ARR. Now it's time to ask yourself a few questions. Thank you for choosing SPMM course for your revision.